Okay. Look at the first table. The number of workers engaged in loading are given 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the second row, number of boxes loaded per day. These two can be given in a problem. What we may be or what we should be rather able to find out is marginal product. So one worker 90 have produced. Second worker, the production came to 200. The difference is 110. That is the marginal product. From 200 to 315, it increased by 115. So the third worker's marginal productivity is 115. From 315 to 420, the fourth worker has brought in additional 105 loading. That means additional productivity brought in by the worker is what you call as marginal productivity of that worker. Average is nothing but dividing the number of boxes loaded or the produce by the number of inputs engaged. For example, 500 boxes are loaded by 5 people. See, 500 boxes by 5 people. So if you divide 500 by this 5, you get 100. That is the average. Same is the case. 200 by 2. So 200 divided by 2, it came to 100. So that is the average productivity. So that is how marginal productivity and average productivity of worker are being found out. Now let's look at another problem. The total cost function of optical cable manufacturing facility in Noida is given by TC is equal to 24Q minus 9Q square plus 7Q cube. Okay, what will be the average cost function? So what will be the average cost? Average cost will always be total cost by number of units produced, or here quantity. See, Q represents quantity in such functions. So total cost by average cost is equal to total cost by quantity. So divide this equation by Q. 24Q minus 9Q square plus 7Q cube by Q. What will this lead to? 24 minus 9Q, Q square becomes Q, right? And Q cube becomes Q square, 7Q square. This is the average cost curve. This is what he has asked in the problem. Let's move to the next problem. The total cost function of an optical cable manufacturing facility, same thing is given. What will be the marginal cost function? Just now we have calculated average cost. Now he wants us to find out marginal cost. How do you get the marginal cost? This is answered. This will not be given in the question. We get marginal cost by applying the first order differentiation. So how do you get it? MC is equal to dou of TC by dou Q, because generally you do it by dy by dx. Here x is quantity Q, so dou of TC by TQ, that is equal to, or that implies marginal cost is equal to 24Q. I am taking it from here. See, I am lifting it directly from the ground. 24Q minus 9Q square plus 7Q cube. You differentiate with quantity. Sorry, small q quantity. So what will it become? That becomes MC is equal to 24Q means, see, d by dx of anything becomes for example, a to the x to the power of n, then it becomes nx n minus 1. That is how you get it. So MC is equal to 24 minus 9Q square, 2 into 9, 18, Q square 2 minus 1, Q only, plus 3 into 7, 21, Q cube minus Q to the power of 3 minus 1 is Q square. So MC will become 24 minus 18Q plus 21Q square. Let's look at another problem. The total cost function of a firm is TC is equal to 3q minus 6q square plus 3q cube. Find out the output which minimizes the average cost. So if you recall, we have seen graphs, okay, where the average cost curve intersects the marginal cost at its average cost lowest point. Average variable cost curve, and this is marginal cost curve. The marginal cost curve intersects the average variable cost at its lowest point. So where MC is equal to AVC, or average variable cost, at that point you will be having the minimum cost. Okay, so let's do it. How do you get average cost? Average cost is equal to TC by Q. In the first problem today we have done it. That is equal to 36Q minus 6Q square plus 3Q cube whole by 3. So AC implies AC is equal to 36 minus 6Q plus 3Q square, right? The power of Q reduces by 1. Now what is the marginal cost? You get marginal cost by applying first set of differentiation, right? So let's do it. MC is equal to first set of differentiation for okay, dou TC by dou of Q, that is equal to, see how that happens. Q to the power of 1 becomes Q to the power of 0, that is 1. So 36 remains as 36, okay, minus 2 into 6, 12, Q square becomes Q plus, this is cube, right, 3 into 3, 9, plus Q cube becomes Q square. So this is MC is equal to 36 minus 12Q plus 9Q square plus, this is Q, 9Q square. So we need to, the lowest point is MC is equal to average variable cost, or see both average variable cost and average cost curves. This is average variable cost, this is average total cost, right? Today we have seen that at their lowest points marginal cost intersects them. So if this is the marginal cost and that is the average cost, they should be equal at that point, right? So the minimizing point, how do you get it? At AC is equal to MC, at which point both of them are equal, the cost will be minimum. So let's equate them. AC is equal to MC. 36 minus, I'm taking AC here from here, okay, minus 6Q plus 3Q square is equal to 36 minus 12Q, taking from here, just found out, right, plus 9Q square. If you equate this, so 36 get cancelled, minus 6Q minus 12Q. So what remains here? Just 6Q. 6Q is equal to this minus 12Q. If it this minus 12Q, if it comes to this side, it becomes plus 12Q. 12Q minus 6Q is 6Q. Okay. This 3Q square, if you take to the right hand side, it becomes minus 3Q. So 6Q is equal to, sorry, 9Q square minus 3Q square. Minus this 3Q square from the left, it becomes minus. So what happened? 6Q is equal to 6Q square. When can 6Q be equal to 6Q square? Okay, 6 square, Q is equal to Q square. At Q is equal to 1, because 1 square is also 1. That is why Q is equal to 1 is the answer. Okay, so these three are important. Like this, we should be able to solve the problem.